Use Simpson's rule with 5 ordinates to find an approximate value for the integral of e of x squared between 0 and 1. Show your working and give your answer correct to 4 decimal places. Part B. Use your answer to Part A to deduce an approximate value for the integral e to the x squared plus 3 dx between 0 and 1. So let's have a look at this then. Okay, so here's the question in summary form. So we need Simpson's rule for Part A, don't we? So let's have a look at that. So here's the formula then. Now we've got 5 ordinates, so that means n is 4, isn't it? So let's put that in. N is 4, so that's y4. Here's the formula from the formula book. And then this goes up. We're only going to go, the odds are only y1 and y3, aren't they? So I can get rid of this stuff here. And then 2y2, the y4 is the first and the last, and these are the evens in between. So we don't need y4 there, which is illustrated in the formula. So it's just 2 lots of y2, isn't it? So that's what we've got then. So let's try and tidy this up a bit. Here's our formula then. And we now need to work out h first of all then. H is b minus a. 1 minus 0 is 1 over n. N is 4, isn't it? So it's a quarter. H is a quarter. So let's put that in. H is a quarter. So h over 3 will be 1/12, won't it? So let's put that in as well. So that's 1 over 12. 1/4 over 3 is 1/12. So we need the ordinates y1 to y4 for e of x squared, isn't it? So let's do that then. So x0, x1, x2, x3 and x4. We're starting from 0 and we're going to 1. And we're going up in increments of a quarter, aren't we? So this is 0.25, 0.5 and 0.75. So that's what we've got then. In each case we need to work out the y ordinates. So we'll put them down now. So y0, put 0 into e to the 0 squared is e to the 0, which is 1. And then here put 1 in, we've got e to the 1 squared, which is e to the 1 is e. Then a quarter, e to the 1 over 16 is here. And this one a half in, e to the quarter. And this one 3/4 is 9/16, isn't it? So this is e to the 9/16. So we could leave it like this, keep it perfectly accurate in the first instance when we're working out this formula. So if we label this I then, so I equals then, it's 1/12, y1 plus y4, so that's 1 plus e, plus 4 lots of y1 and y3, isn't it, these two? So that's e to the 1 over 16 plus e to the 9 over 16 plus 2 lots of y2, which is this one here, which is e to the 1/4. And then we close the bracket. So we need to type that in the calculator. And we're working out the problem to 4 decimal places, aren't we? So let's work that out then. So type it in the calculator. We've got 1 plus e plus shift e, cancel. Sorry, 1 plus, I'll get it right in a minute. There's the e to the power 1. There we are. And it's a plus, isn't it? Right, 1 plus e, it'll be times the 12th, won't it? So it's 1 over 12 in front. Just getting up to speed with this, aren't I? Bracket, there we are. 1 divided by 12, 1 plus e to the 1, plus 4, times bracket, e to the 16, power 16th. So that's 1 divided by 16, plus e to the 9/16, 9 divided by 16, back to ground level. So that's that one done. Close bracket, plus 2. And then it's just e to the quarter. So it's shift ln, which is e, to the 1 divided by 4, which is a quarter. back to ground level, close the brace at the end, press equals 1.4637 to 4 dp, 1.4637. That's the 4 decimal places. Okay, so there's that done. Now we need to find this integral here, the approximate integral here. So part B here. Let's call this I again now. I is equal to, for the second part of the problem, well, it's basically 0 to 1 of e to the properties of indices times you add on indices, so it's e to the x squared times e cubed dx, which is equal to e cubed times the integral of 0 to 1 of e to the x squared dx. So we have to times our integral, which is this value here, by e cubed. So it's in the calculator already. So times that by e cubed, power 3, 23.3994, 29.3994, 29.3994, and that's the 4 decimal places. Okay, that's approximately equal to, because this is using Simpson's rule, isn't it, here, for the integral value. Okay, good.